February 1, 1980, to test for what paragraph 3431, SIF ditch. Set the 137 as in a normal setup, and with a signal level of MTL plus 50, run in a substitute pulse triggered from the SLS out into a type 115 pulse generator, and the 115 pulse generator to modulate the AUX mod in on the 137. Observe test point 2, 4. Observe test point 4 on the A2 card, and with the AUX attenuator set for MTL plus 3, run the delay of the substitution pulse into a point to where 50% countdown is observed on the test point. And this timing is approximately 13.7 microseconds and is the SIF ditch recovery time to within 3 dB as per the specification.
Do you stop it?
Okay, place the test probe in TP2 and display on the A scope the interrogation signal plus the TP2 video, and with the signal level set for MTL. Okay, with the signal level set from MTL plus 3 on up in the dynamic range to plus 50, observe that the flat portion of the test point pulse generated by the interrogation stays within the range of 2 to 4 microseconds. The pulse rises up and then sort of stays flat and then drops slightly and then drops off sharp down to the next interrogation pulse, or the P3 pulse. Okay, SLS action on this APX 100 transponder. With the signal level set for MTL plus 3, set the SLS AUX attenuator to give 50% replies, and at this point it gives us 3.8 dB for 50% replies at MTL plus 3. Increase the signal level to MTL plus 6 and then readjust the AUX attenuator to give 50% replies. Increase signal level to MTL plus 10 and adjust AUX attenuator again to give 50% replies. Increase signal to MTL plus 20 and do the same thing. Increase to 30, 40, 50, and 55 on the AUX on the main signal attenuator MTL plus these numbers, and take the same readings. All the above tests should be run with a normal interrogation, normal pulse width, SIF mode, and the SLS positioned in a normal position. This test was ran on the APX 100 set for the diversity mode. Rerun of APX 100 February 4, 1980. Reran the SIF SLS operation. About 3 different methods were used to compare the signal amplitudes. One of them was the AUX attenuator only. One of them was AUX attenuator and the main attenuator compared in the standard video detector that we use. The second method was to use the receiver video test point 1 in the APX 100, and the third method we used was using the 436A Hewlett-Packard power meter and measured the signal differential between the output attenuator on the 137 and the AUX attenuator on the 137. SLS run on the mode 4 word, use the 137 fixed word A, use a substitute pulse into the AUX mod out of a type 115 pulse generator, triggered externally from the delayed trigger. Adjust the pulse width and compare the amplitudes to the main attenuator through an external RF detector, the normal detector we used. Put an offset in the offset channel and set the diversity switch for top antenna and put 10 dB of attenuation in the offset. Okay, use 50% reply criteria. We got a total PRF of 500, so that would be 250. Okay, add 10 dB of offset attenuation into the top channel and take out 10 dB of offset for the bottom channel. Throw the switch to the bottom and rerun the Mode 4 SLS test.
Double check on that.
The data points throughout the dynamic range are MTL plus 3, plus 6, plus 10, 20, 30, 40, 50, and 55.
Okay.
Okay, to check train droop in the receiver, run the substitution pulse out towards the end of the 137's A word and put it in the last zero position, which is we're setting at 2 microseconds from next to the last pulse. Okay, use the aux attenuator and increase the signal level to a point that gives you 50% replies. These tests are taken at MTL plus 6. Also, at this point in the Mode 4 receiver train droop, challenge video could be monitored and for observation of the 50% countdown of the substitution pulse. Increase the signal level to MTL plus 50 and repeat the same test with the substitution pulse out at the end of the word, 2 microseconds from next to the last pulse, 50% replies, and also observation on the challenge video line. Okay, run the substitution pulse back to the P5 position, recheck the time and the spacing and equal amplitudes for the 137 attenuators, and recheck the reference at MTL plus 50. Okay, that was Mode 4 ditch 3.4.3.2. in the test procedure. Okay, for ditch length test, observe TP2 on the A2 card in the APX 100. This gives a big positive going gate. Run the substitution pulse at about MTL plus 3 or so, and run it out in delay until it appears about 50% of the time just past the gate observed on TP2, and set it for a visual 50% reply and measure this time somewhere in the neighborhood of 95, 96 microseconds. To test a reset time of the ditch in the Mode 4, connect the scope probe to the disparity line and also to the test point 2 on the A2 card, which is the ditch line. Enable the A disparity on the AB disparity on the 137 and set the scope up to measure the time from the disparity pulse to the recovery time of the ditch in about 3/4 of a microsecond. Signal level MTL plus 30. Okay, February 5, 1980 APX 100 test, strong pulse desensitization test. Put the main signal, the A word, into the aux attenuator and set it about 10-20 dB on the dial. Put the sub pulse into the main mod and with the main attenuator set for 0 and about MTL plus 30 on the signal level. See that it doesn't cause any countdown. It's a strong pulse desensitization test. Okay, sorry about that. Sync pattern ditch lock test. Switch the 137 to tag reset and supply a Mode 4 sync pattern and observe challenge video or detected video on the oscilloscope and also TP2 on the A2 card, which is the ditch signal test point. Use the M41 sub pulse on the 137 and move the P1 pulse away from the other 3 in the sync pattern and observe that when it's in the position to decode properly, you get a ditch lock, which is a squared off signal for about 14 microseconds, and then when you move it out of the decode position with a sub pulse, notice that the ditch recovers with an angular sort of recovery time. It's also at MTL plus 30. for the main signal. Okay, a test to check for ditch level set on a mode 4 sync pattern. Use the sub pulse again and run the P1 pulse in on top of the P2 pulse on the 137 to eliminate it. Then introduce a sub pulse into the aux mod and position it into the P1 position. Vary the aux attenuator over its range with the main signal set at MTL plus 30. Ditch lock takes place as soon as the P1 pulse reaches MTL, and the ditch lock then stays locked to a signal level plus 3 or more of the rest of the sync pattern. All this is ran at MTL plus 30. Okay, mode 4 AOC test. Interrogate the transponder at MTL plus 50 with 1900 pulses per second trigger rate, and measure the number of replies for the bottom and the top channel individually. Okay, standard test condition for mode 4 AOC with the machine set in a diversity position and MTL plus 6 with 1100 trigger rate with an offset favoring the top channel by 9 dB or so. The output count is 974, and it should put out 1,000 counts. AOC test mode 4 with the 1100 pulses in. Check the top and bottom antennas, processing systems, MTL plus 6, 10, 20, 30, 40, 50, and 55. Ran into a problem trying to offset bottom channel from the top channel and had to terminate the top channel antenna and run the bottom channel by itself because of switch over to the top channel. Several AOC tests were ran on this 100 top and bottom channel. The channels were split mostly by terminating one channel with a load and using the other channel as far as separation goes. Bottom channel showed a severe lockout problem when the trigger rate exceeded the AOC set level rate and caused a lockout over the full dynamic range, somewhat dependent on PRF. Test was ran using the mode 4 fixed word out of the 137 for all levels above 1900 PRF. Okay, SIF reply rate limit using the 137, interrogating the transponder in mode 2, and the channels will be separated by terminating one channel and interrogating in the other with the top-bottom select switch in the diversity position. Okay, with MTL plus 6 and the interrogation rate set for 1300 in, bottom channel replies at 1100. Increase the signal level to MTL plus 50, and here again it reads 1100. Okay, increase PRF to 1900 and run the same test. At MTL plus 50 replies 1099, and at plus 6 it's 1108. Okay, with the 4000 PRF into the 100 and swinging it over the dynamic range, the rate stays up pretty good and solid throughout the range for the bottom antenna. Okay, top antenna is connected now with the PRF at 4000, and it still maintains 1100 or so over the dynamic range. Looks alright with no holes in it. The test for factory setting is MTL plus 6 and 1300 pulsed in, and the reply rate is 1107. 1100 instead of, and at MTL plus 50, 1104. Increase PRF to 1900. Run the signal level to MTL plus 50, and the reply rate is 1106. Okay, with the 100 set for diversity operation with equal signal levels in and a PRF of 4000, it displays no holes throughout the dynamic range, and the count is mostly on the top channel, except back around MTL, and then some of it splits off to the bottom channel. Okay, to check the limit of SIF adjustments, we're going on to the A2 card and adjust the pot to control the bottom channel. The channels are separated, one of them's terminated. Okay, bottom channel reply rate limit for the SIF went to in excess of 5,000 pulses per second and no degradation over the dynamic range. For duty cycle test, while the AOC rates are set high for the SIF, they add 4 sevens to the reply and increase the PRF until countdown is observed. This countdown should give you something in excess of 1% duty cycle. Run the signal level over the dynamic range to make sure there's no holes in it, and it looks okay. Okay, to test for duty cycle turn down of mode 4 interrogations, set the PRF of the SIF to 2500 with 4 sevens on the reply, which puts it into duty cycle limit with the AOC cranked well above that point. Synchronize a type 114 pulse generator off of the 137's delay trigger. Set the 114 for external trigger, the width range for 1 millisecond, and adjust the variable to produce a counted down PRF of about 100, 104, somewhere along there. Then trigger the type 115 pulse generator and set the mode 4 interrogation to a point in between any pair of the SIF interrogations. Run the oscilloscope with the variable time multiplier in the uncalibrated position to stop the 100 rate from free running through the oscilloscope display to set this delay time. The mode 4 should not be counted down. Should be no countdown caused by the duty cycle limit of the SIF at this point. Run the signal level over the dynamic range to make sure that the mode 4 count stays approximately the same. Okay, reset the channel reply rate back to 1100 with 1300 triggers in and an MTL plus 6. Okay, top channel at MTL plus 50 and the interrogation rate set for 1900 and the reply rate is 1116. Okay, reset the top channel AOC to 1100 with 1300 triggers in at MTL plus 6. To do SIF cross channel AOC, set up two 137s. One of them at MTL plus 3, the other one at MTL plus 50. Put the MTL plus 50 into the bottom channel and the MTL plus 3 into the top channel. Set up a rate of 1900 pulses per second into the MTL plus 50 channel and take the delayed trigger out and put it into the input of the gate. Take the output of the gate out and trigger the second 137. The second 137 is set up for mode 2 challenges, and the MTL plus 50 137 is set up for mode 3 challenges. Set up a type 115 pulse generator triggered off of the SLS out of the plus 50 137 and take the output of the 115 pulse generator and trigger a type 114 pulse generator. Take the output of the 114 pulse generator and go into the gate in on the gate box. Display triggers in and gate in on the test oscilloscope and use a long sweep somewhere 1 millisecond per centimeter and take it out of or leave it in the calibrated position. It'd be alright. Adjust the width on the 114 pulse generator to the 1 millisecond range, and then by observation on the test oscilloscope observe the number of triggers gated out to the second 137 in order to adjust the output trigger rate of the second 137. This rate should adjust somewhere from full firing 1900 PRF down to well, whatever. In one case, it puts out 1588 pulses, and that's 1, 2, 3, 4, 5 out of 6. of the 1900. The output out of the APX 100, once you exceed 640 or so replies out of the top channel, or the MTL plus 3 channel, should remain pretty constant, about half of the replies out of each channel. Up until that point, the bottom channel, or the MTL plus 50, should exceed the top channel, depending on the rate applied to the top channel. Okay, APX 100 test, February 6th, 1980. Mode 4 AOC, cross-channel desensitization, running with a heavily loaded channel at 1400 pulses per second, coming out of 137 number 1 at MTL plus 50, going into the bottom channel. We did 3 Tektronix counters, 115 being triggered from a side lobe suppression trigger out of the 137 number 1. That's delay triggering a 114 generator, which is set for negative pulse, 1 to 3 volts and 1 millisecond, which in turn triggers another 115A generator, which regenerates a positive trigger to trigger the 137 number 2, which is set at MTL plus 3, and the combination of these 3 pulse generators will give us a counted down and synchronized second mode 4 word. We're using a type A word out of 137 number 2, which is at MTL plus 3, and the combination of pulse generators should allow us to run the rate from some minimum value up to 1400 for the lightly loaded channel. Okay, paragraph 3.4.6.5 ISLS rate limit, set up at 137 for an SIF interrogation with the side lobe action, run the rate up somewhere in the neighborhood of 7400. Observe test point 3 on the A3 card, a negative going signal, about 35 microseconds long. Should observe a countdown in this signal when the rate is exceeded. Check it at MTL plus 6 and plus 50. Okay, to run suppression of mode 4 reply, run in behind a mode 4 interrogation, run in behind a mode 4 reply. Set up 2 137s, one of them with a fixed mode 4 word, interrogating the transponder. Set up a sync pattern out of the second 137, delayed by the delay trigger, and put the second 137's modulation into the AUX mod, which puts them both into the transponder at the same RF level when set on 0 attenuation. With the delayed trigger, run the mode 4 sync pattern in behind the mode 4 reply. Display on the oscilloscope the detected mode 4 reply, the detected interrogation signal, the mode 4 trigger, enable trigger, and the A2 TP13 test point, and measure the delay time from the P3 reply pulse to the end of the gate on test point 13 on the A2 card, and also the next interrogation, somewhere less than 2 microseconds for the interrogation and about 2.5 microseconds for the gate on the test point 13. These tests were run at MTL plus 20. February the 7th, 1980, APX 100 test continuing. Okay, to check mode 4 suppression time 2, follow on mode 4, enable a type 1 disparity on the number 137, which has the A word in it. To do this, enable the SLS. It gives a type 1 disparity that happens somewhere after the word. Then run in the second mode 4 sync pattern from the second 137, and display the disparity on the oscilloscope and the detected RF. Measure the look for triggers to the second, or the mode 4 sync pattern, and crank the delay in until the trigger is about 50% replies, and measure the time between the disparity pulse and the first or the P1 pulse of the follow-on sync pattern, somewhere in the neighborhood of 100 nanoseconds. Test ran at MTL plus 20. To check mode 4 suppression of an SIF signal, run a SIF interrogation in between the mode 4 into the mode 4 word and the mode 4 reply, and decrease the delay moving towards the word until you start to achieve 50% countdown on the SIF reply. Then measure the delay time from the P4 of the mode 4 train to the P1 of the SIF train, somewhere in the neighborhood of 92.3 microseconds. This test it ran at MTL plus 20 with equal signal levels. For mode 4 suppression of SIF in and about the reply time, run an SIF signal in behind the reply using a mode 4 fixed word and an SIF mode. Display them on the scope and measure the time from P3 of the reply, mode 4 reply, to the P1 of the SIF interrogation. To check the suppression on the inside of the mode 4 reply, run the SIF interrogation inside the mode 4 reply and then back it up until the last, or the F2 pulse, starts to count down, and then measure the time from the leading edge of the F2 pulse to the leading edge of the P1 pulse in the mode 4 reply, around 900 nanoseconds. February 8, 1980 APX100 test to check the effects of external suppression. Use type 115 pulse generator and monitor on the oscilloscope on the A3 card TP12. Monitor on the oscilloscope the suppression generated by the external trigger input. Put the external trigger input into the suppression in aims and monitor the input on the oscilloscope as well as the test point. Adjust the type 115 pulse generator to produce a rise time of 1 microsecond per 10 volts. Run an SIF train in behind the suppression to check the point at which the transponder is suppressed to. Turn the tape over to side A for the remaining tests.
Why did you not put it in here?
You can also remotely select remote.
Is that properly labeled here? We don't use select. What's the code on this?
No, there's also a remote. Yeah, I hope it's in the book. It was in the original manual. You also can select remote for selection of these switches. And now these switches on the front don't do anything, and these switches over here do. If you really want to.
Where again is that remote?
That's right.
Okay.
Yeah. In normal operation, I would think you would want to use the operation in the
Which has variable rise and fall time settings as well as a DC offset setting. Adjust the knobs on the output driver to give you a suitable pulse about 3.5 microseconds wide with a rise time of 2 microseconds and fall time of about 2 microseconds. RF, that's detected RF pulses using a standard detector. Adjust the modulation drive after, well, insert the signal into the RF mixer network and display a mode, SIF mode interrogation and the 612 signal, and adjust the modulation until you don't see any CW beat or very little CW beat in the SIF interrogation signal. Then take out the SIF signal and run the pulses, the TACAN simulated pulses against the APX100, and run the main attenuator over the combined attenuator, sorry about that, over the range, and observe SIF replies or challenge video mode 4 triggers. You may expect to see some mode 1 replies that signals MTL plus 10 or so.
You can use all 4 simultaneously.
You can?
Yeah, if you want to, or you can use them one at a time. There's an enable-disable switch on all 4 of them.
Can you get something corresponding to that over there?
No, you just...
Whatever you set over there, you gotta...
Yeah, I'm just setting AII switches over here. Like I said, bits 6 through 13. 8 bits correspond to these 8 bits.
Well, let me write this down. This is kind
1,
of
2,
damn stuff.
3, 4, 5, 6, 7, 8. These bits should really be labeled 6 through 13 instead of 0 through 7. I don't know who labeled it, but the front panel was made that way, and it's a little confusing.
Bits.
So now you can see that if I turn one of these off, I get a disparity. This light has a delay on it. There's a relay. Now you can hear the relay click if I...
Yeah.
Well, there's a relay in there, and you can tie the relay to something, and this thing has a similar delay to that light over there. If I turn that off, I don't know, it's close. It's the same as the light over there.
Bits 6 through 13 on the interrogator end, right?
So if I turn all this up, the next one should authenticate. If I enable it. Yeah, you can really control 4 functions with these 4 relays, these authentication relays. Right now we have 4 lights attached to them, so you don't want to connect anything to it. But in normal operation, if you would want to control something with a relay, depending on whether you're getting authentication or not. When you don't get an authentication, it truncates the video coming out of the... Let's disable one of these. If you look at the video coming out of the transponder, when I'm unauthenticated, it truncates it. It's syncing on the wrong one, but you get about the first data bit, and then it's truncated after that.
Okay.
So you generate a disparity.
So let's set. Oh, we can enable all 4 of these, right,
Yeah,
on this transponder module. So we'll enable all 4 of these. We'll put 1. You can do 2 of them, can you, like that?
Yeah.
Well, how do these relate to only
Okay,
one set
now,
of switches over there?
when we go over here to the interrogator module,
Okay,
now in order to get an authentication on channel 1 on the transponder module, you enable
6.
bit 6. Okay,
Only
and that
bit
does
6?
it and lights this.
Yeah.
Okay, now, well, maybe we should make it similar. Let's make it 01, 02, and 03. Would that be simpler?
Yeah, well, it's only going to authenticate on this one because you have to have this exact pattern. You have
That's right.
1 and
Okay.
7 zeros.
Now,
if I
they authenticate on the next one.
turn that on, bit 7 authenticates on the next one.
Okay, now the next one, let's see now, in order to do this, you enable switches, what'd you say, 6?
6 through 13.
6 through 13 on the interrogator module. And that gives an authentication with the authentication code in the transponder module, depending on what you have selected on the select switches and the enable disable switch. Okay, let's try that's number 3. Let's try number 4, which is 3. Okay, that exercises all 4 of these functions. All right.
Yeah.
I'm not in left field.
You can also use that authentication to generate a secure IP reply. When bit 2 enables a secure IP reply. If you look at
Now that's
providing
a code here matches the code over here, right?
Yeah, it's right. Now this is...
We were playing with that yesterday.
Now
So
the secure IP... The data set on switch 3, 4, and 5 identify which secure IP you're going to get. Right now, 3, 4, and 5 are 0. That indicates that I'm going to reply with the PAL identification that I'm transmitting. If I put a 1 in there, binary sequence 1, it'll reply with code 1 if it's enabled over here. You have to enable code 1. Let's see which way is enable. Enable is middle switch. It'll reply with the code 1, and you have to enable it. If you don't have it enabled, you'll get a framing pulse, but you won't get a code out.
how come it don't transmit out over there?
Last time I was here, this input to your aux trigger didn't work. If you look at this...
did you disconnect that?
No.
No.
Alright, now it's doing it. We had it doing it yesterday.
Okay, so now you get the framing. If I go back and just put 3, it'll reply with 77, which is what's on the PAL signature. If I change the PAL signature, I'm not using PAL.
Now secure IP is enabling switch 2 on the AII switches.
Yes, there is an internal switch here that you can disable this function if you don't want it to give you a secure IP. But this authentication code will prevent that secure IP if it doesn't authenticate. Let's see, what am I at here?
Prevents a reply at all.
Prevent a reply, which prevents the secure IP. Yeah. So, in the book it tells
it'll
you...
prevent the reply even without the secure IP. The secure IP really doesn't have anything to do with it.
Yeah.
Right? Authentication is only...
Yeah, it's just another function. So one replies, should reply with this code when it's enabled. It should reply with code 1 when it's enabled. You can see when I enable it, it comes on.
That's the code set on these thumb wheel switches?
Yeah. And if I put a 2 in, which is a binary 2, that's a 1 on bit 4, it should respond to the code that's in 2.
You got that?
Got that?
Just leave it in the dust.
See, if I put a binary
that's all right.
on there,
That's an in-depth demonstration.
respond to what's on the thumb wheel of group 3.
Are all these codes for the interrogator module in your tech manual? To tell you what those, I know the 2 is. I found that yesterday, and I was playing with secure IP.
I think after you get above 4, you just get the framing pulses. It gives you a list.
Well, we're not worried about getting above 4. Let's just forget about getting above 4.
You got that?
You got it all right here.
How
You
about
understand
here?
what the hell it is? It's all in this
That's
box.
why it better be in that
You
box.
switching that off and on when there's
No,
no
I'm
talking?
just leaving it on because you never know when something important will
I'm
come
going to
out.
say something, but I was just going to...
Important is absolutely random function.
It does so many functions that...
I can see right off the watch.
Really?
Okay, check page 11 in the interrogator module instruction manual for the AII pulse positions for verification.
You select?
Switch 6 gives us that. Okay.
Oh, concept.
Enabling 2 and 3 gives us brackets, looks like.
Yeah, you have to enable down here. If you enable all 4 words,
Okay.
it'll reply with all 4.
Yeah, let's do that.
You also can...
Okay, now, if I exercise, select AII position 2, and that gives me channel 1 over there on the...
they're all zeros. It gives you the PAL ID, which I'm not transmitting up. I'm not sure where it's getting it. So I don't think you should.
Here's your key.
Well,
You got 6 through 13, and what in the hell do they do?
you transmit those 8 bits, and they're received here, and
How does that relate to this?
these 8 bits have to be identical to these 8 bits to enable a reply.
Okay.
This is an OR function.
That's if these didn't exist, I believe that.
Yeah. Well, it's like an OR function. It's either this code, if you have them all enabled, it's either this code or this code or this code or this code will enable a reply when they're all enabled.
It's got to feel for one.
So,
Well, how do you select which one is going to enable?
well, if you only want one, you disable all the other 3. Now there's only one code that'll enable it.
That's when you have 4 different
Well, let's back up one more time.
Or you may want...
The purpose of authentication is to send a code out here on the AII bits, on 8 selected bits. You're going to look at those, and you're going to match that with something you got in the transponder. And if they match, then that's a good mode
enable a
forward, and you go
reply.
ahead with it.
You also close this relay here, which can control something. There's a relay in there.
If they authenticate.
Yeah, if they authenticate. If they don't authenticate,
All right, one more time. How in the hell do you use 4 of these when you've only got 8 bits over there to set up the interrogation part of it?
well, these 8 bits are the same. It's either 6 through 13 has to be identical to either this code or this code.
Any one of them.
Or this code, yeah, when they're enabled. But you don't have to enable all 4 at once. You can enable 1, you can enable 3 or 4 or whatever you want. And you can set the same code or different code.
Well, what's the purpose of having 4 then?
It's 4 channels of control, okay? If
Yeah,
you got 4 functions you want to control. You
When you
control
get,
them from this.
you may say when you
from
get
the
bit
down, from this
6,
lane.
you want to close this relay. When you get bit 7, you set bit 7 over here. You want to close this relay and control something.
Well, what is
And
that for you?
bit 8, you want to control this.
I
So
don't
you
know.
can simultaneously control.
It's just a control function. That's part of this data link. That's all it is. The data
Well, I'm
link
trying to
gives you a
figure
relay
out what-
closure in the airplane.
Yeah, well,
Yeah.
what's the purpose?
Well, you can turn on a little sign that says it's lunchtime, or
Yeah, you can turn on a light like that.
Yeah.
It says, aha, the guy's...
The pilot can say, okay, drop big bombs, drop little bombs, drop whatever, you know, turn around and come
Yeah, we
home, buy
put
nothing more than lights, you see, four
Yeah.
functions.
Yeah. It's not intended to be something that's installable in an airplane.
Oh,
It's
it's
something
more
for
than four
demonstration
functions.
purposes.
You could use all four of them or any combination of those
Yeah, it's
four.
really
So
16.
you got 16 possible functions with four relays.
Well, they're not in, though.
Oh, you can't light two of
Well-
them simultaneously?
Yeah, I guess, yeah, you can if you got to set the same code, though. Like if I set the same code in both of them. So it's not really...
Let's just stick with word 1.
See, I can light both of them, but I've had the same code in both.
Right, but
so
we can't do it. Okay,
they're not
you can only
really
do
separately definable, so they're only really
Yeah.
4. Even though they can work in parallel, you really wouldn't want to do that. You might as well run them all
four. Yeah,
one.
right. Okay, so it's only four functions. It's not 16.
Yeah.
You should be able to light all these lights with just this bunch, right?
No.
No, just the
It's
first.
only connected to one light. If I want to light the second one, I enable this one and turn on that bit. If I want to enable the third one, I enable that one and turn on the same bit. And the fourth one.
Okay, set a different bit in each one of them and we'll control it from over here.
Yeah.
Wait a minute.
Maybe that's a little better, I think, to look at, to understand what's happening.
Okay. These have the same delay as the light over there.
Now, what happens is you set the code right here on bits 6 through 13, right?
Yeah.
Okay, now that's bit 6. That's got that one. Now, if I go this,
You got the
it catches the next one. That's bit 7. Turn it off. Bit 8
Yeah.
and 9.
What the hell do you do with the rest of the bits?
Yeah, what do you do with the rest of them?
Well,
63.
you can. It's really not set up to use more
Oh,
than
it
8.
lights more lights over
Yeah,
there.
to light all the lights.
It lights all the lights.
There's
So you
also-
can put all these on here
Yeah.
through 13.
They only requested capability to
Yeah.
use 8, but you could. In a production,
8.
you would really do something with all the bits.
7,
You
6.
want to use them.
Oh, this is not lighting the authentication now, though.
Well, you got a different combination. It's not one bit at a time. You've got all ones. If I put all ones in here, it'll light.
Oh, that's still sensitive to the other bits.
It's all the bits, not just one bit.
Okay.
It's 6
I
through
see.
13. See, what do you have now? 2 bits?
That's 2 bits.
Okay, if I put 2 bits up, now it'll light it.
Okay.
Okay, now 3 bits.
I see what it's doing.
If I put 3 bits up, it'll light it. Okay, 4. 5, 6, 7, 8. See, it's sensitive to all 8 bits, so you've got to have 1 and 7 zeros if you.
Now, if I turn them all off, it'll do the next one. Okay.
Well, yeah.
In order to get that first one on again, I've got to do all these guys.
And you always got to do that?
Yeah.
Why is
Okay.
that?
Okay, the PAL signature is controlled by this group, the PAL ident group. Turn that on, it puts the PAL signature in, and the PAL signature which it inserts is controlled by this switch. There are 4 selectable PAL IDs in the group. There's a remote switch where you can go remote and enter a remote PAL ID.
Are there 4 more over here?
No, it's just one
No,
on the
if there's
remote.
one,
Oh.
you can enter remote. You can build a remote guy that orders them in or something. So you really have 5. Right now I have all 1s set in. You can also put in X pulses and SPI pulses with the PAL signature. And then get stuff in and fix delay in front of the mode forward. On the transponder you have 2 switches here. The first switch enables the PAL signature, and it has to correlate with when it's set on transponder, which is TSPR, has to correlate with the 4 thumb wheel switches on the 72. When it's set on remote, it's going to correlate with the remote switches on the test box. I think
So
I've
you
got
got
the
2.
same. If I turn this off, it'll stop replying.
2 possibilities
If I change
here.
one.
1 set of codes over there and 1 on the front panel.
Yeah.
Transponder.
And in the PAL mode, all the AII and secure IP and verification functions work too. So you can require the PAL signature to correlate, and also 8 verification bits before you reply. If you want to do that, enable one of these like such. If I turn that on, it'll stop replying. Stop replying. So right now it's 8-0, so it'll reply.
Oh, okay, you got it all zero.
Yeah, so it replies since they correlate. Then you can turn on the secure IP and that'll work. Okay, that's the PAL signature. Now the next step is dual interrogation. To enable dual interrogation, you have to flip on the A4 board.
Hold it. Pass over that piece.
I'm going to get my little sheet here. I'll tell you which switch is there. I have to write this down because I don't know what all the switches do myself.
On the IR board,
On the A4 board in the interrogator, you have to switch 3 and 4 to the 1 position, and they're the top 2 switches on the A4 board for each down here.
top,
Yeah.
2,
Yeah, we should remember by switch 3 and 4, they're marked on there by numbers, so
numbers 3 and 4, right?
yeah, that's the easier way. Flip both of those to the 1 position, which is to the right. That enables
Switch them to the right. Setting up normal.
Yeah. The dual interrogation mode was intended. Oh, wait a minute, I've got to go back to this thing. You gotta run out of the interrogation store to generate the dual interrogations. Okay. It was intended to have a PAL signature on the first one, first interrogation with AII functions, and a normal move forward for the second interrogation with no PAL signature and no AII functions. It also works by turning off the PAL signature, and you have AII functions on the first one. Let me enable the transponder here to get a reply. So that you have to turn on the A4 board, switch 62 or position 62, switch 4. You turn to 1 and 62 or 69. I'll repeat that: 69, switch 1, and make it 1. Now you're in the dual
I'll give you a switch position.
62, 4, and 69, 1. We're in the 1 position for dual interrogation.
What is 1, right or left?
Right. Rock to the right. Okay. Turn that on. It will reply. It requires a reply from the kit, which is not transmitted, to enable the reply to the second interrogation. The reply to the first interrogation generates a gate, which the enable trigger from the second interrogation has to fall into it to allow a reply to the second interrogation.
It's another form of authentication, Joe. I just want to ask.
Yeah.
It's another
So it does.
one of Leidy's ideas.
It does work with PAL off, although that wasn't really required. It does work with PAL off. AII's in the first and not in the second. You can also, although I haven't put it in the manual, you can also put a PAL signature on the second or AII's on the second, and it'll work too. But if you're interested in that, in some date, I'll tell you how to do it. You have to change the timings on the interrogation store to get the gate to fall right.
Don't boggle my mind.
So,
It's already done.
yeah, I don't think you ever really need to do that, but since it was built that way, it would work. And it's there. So that's a dual interrogation.
Wait a minute, you went too fast on position 69, which switch? Both of them are number 4?
No, switch 1 on
Number
69,
one?
yeah.
Yeah, it's 1 on 69.
And number 4 on 63.
Yeah. Okay. And in that mode, you have all your AII's. You can tell them Kirby. Tell them random data in there. Whatever you want to do. You can authenticate too in that mode. I'll turn authentication on. Stop the reply. Yeah, it authenticates on the AII's in the first pulse. And ignores the first interrogation, that ignores the second interrogation.
Right now we've got all the functions ongoing but stop.
Okay.
Everything, is that right? Is that
Yeah.
a true statement?
To my best of my knowledge, stop is not required to work with dual interrogation, and it doesn't. It's not designed that way.
Well, it doesn't work with dual
It doesn't. I thought it might, because I had never tried it before, but
So
it
the
would
only-
require me to turn off the stop mode automatically during the second interrogation, and I don't do that. That would be fairly easy to do, but I haven't really done that.
So we got one exception to the balls out mode, right?
Yeah, stop.
That means if you add stop, you got to take out power. Or rather,
Dual interrogation.
Dual interrogation.
Yeah, they were really separate modes, and they were added. Dual interrogation was added first, and stop was added later. And there was really no requirement to be compatible. So it isn't.
Stop used, must shut off dual interrogation.
Now you have to put that where you're putting them back into position.
Yeah, turn off. So I turn that off.
Turn off the dual interrogation.
Now, let me, before you go any further, I have another question.
Use all
On the 8,
32.
you're talking about the authentication.
Yeah, well, you can also use.
8.
Okay, well, let me go back to 6 words and see.
First, what does stop stand for?
Yeah.
Scrambled time operation.
Yeah, you got it right. I had to think a while. Yeah, that's what it is, something like that. Scramble time operation. Okay, to get
Wait.
what it does. Yeah. Well, what it does, the encryption unit. The encryption unit isn't fast enough to do real-time encryption, so it generates an encryption which is used for a certain period of time, either half a second, 1 second, 2 seconds, or 4 seconds, and that's switch selectable on the E6 board. I think right now it's in the half-second mode. But every half second it generates an encryption and puts that out on the data bits. I call them challenge bits. We call them data bits. Actually, what it does, it takes the 32-bit encrypted word that it generates and it exclusive words that onto the challenge bit by bit. It's the same as the sum function on AIIs. So you have a 56-bit key which you load with a key unit that goes into the encryption unit to generate the word. And you also have 56 bits of data which you put in. Right now we're putting 8 control bits in that are manually controllable, and we're putting 24 bits at a time. And the rest of the bits, the data bits, are filled with 5A's, hexadecimal 5A's. So the 24-bit counter in the interrogator and transponder had to be synced within a very accurate amount to generate the same encryption during the same period. So
You're saying that you encrypt or scramble? We should never use the word encrypt in this for political purposes.
Well,
Both the data and the AII pulses?
well, what?
Both of them?
Yeah, okay, you're saying data pulses. All right, used to your terminology. Yeah, you encrypt all 32 data pulses.